Section 2.1, Symbols and Terminologies. Introduction to Set Theory. A set is a collection of objects. An example of a set is written 2, 4, 6, 8, 10. You can see that the set is written in curly braces. An object X in a set is called an element of the set S. The notation X is an element of S. The element symbol is a curved E. Decide whether the following statements are true or false. 3 is an element of 1, 2, 5, 9, 13. 3 is not in that set, so it is false. 0 is an element of 1, 2, 3. 0 is an element of that set, so it's true. 1/5 is an element of 1/3, 1/4, 1/6. It is not in that set, it is false. The empty set is the set containing no elements. It is sometimes called the null set. The symbol 0 with the line through, or the curly braces with nothing inside, is used to denote the empty set. There are 3 ways we designate a set. The first way is a word description. An example of that is the set of odd numbers less than 11. The second way is the listing method, where we write the set as a list in curly braces. 1, 3, 5, 7, 9. The third way is in set builder notation. It's the set of X such that X is an odd counting number less than 11. The words that go along with those symbols. The set of all X such that X is an odd counting number less than 11. Sets of numbers. The natural numbers or counting numbers. When we first start counting naturally, we start with 1. The natural numbers are the set 1, 2, 3, 4, continuing on. Whole numbers start with 0. Whole numbers include 0. The natural numbers does not include 0. So the whole numbers are 0, 1, 2, 3, 4, continuing on. Integers, the set of whole numbers and their opposites. So the negative whole numbers as well. So -4, -3, -2, -1, 0, 1, 2, 3, 4, continuing to increase and continuing to decrease. Rational numbers are denoted by the letter Q, and it's the set of P divided by Q, such that P and Q are integers, and Q does not equal 0. Rational numbers are often called fractions. Irrational numbers. The set of X, such that X is a real number, cannot be expressed as a quotient of integers. Numbers that cannot be written as fractions, such as square root of 3 and pi. Real numbers. The set of X values, such that X is a number that can be expressed as a decimal. The cardinality of a set is the number of elements in the set. N of A is the representation of the cardinal number of a set. It is read N of A. We're going to find the cardinal number of each set. The set K includes the numbers 2, 4, 8, and 16. There are 4 elements in the set, so n of k equals 4. M equals the set containing the number 0. N of m equals 1. There's 1 element in the set M. B equals the set 1, 1, 2, 2, 3. There are 5 elements listed in that set. However, there are 3 different elements in the set. The cardinality of the set, n of b, equals 3. R equals the set 4, 5, continuing on up to 12 and finishing at 13. Count those numbers, 4, 5, all the way up to 13. There are 10 elements of the set. N of R equals 10. The cardinality of the empty set. How many elements are in the empty set? There are 0. A set S is finite if the cardinal number of a set is a whole number. An example of a finite set is the set 2, 4, 6, and 8. The cardinality of that set equals 4, which is a whole number. A set is infinite if the cardinal number of the set is not a whole number. An example of an infinite set would be the real numbers or the integers or the irrational numbers. All of those sets are infinite sets. 2 sets A and B are equal if every element of set A is an element of set B and every element of set B is an element of set A. An example of equal sets: A is the set 10, 11, 12. B is the set 11, 12, 10. The difference between those sets is only the way the numbers are ordered in set B. So those sets are equal sets. An example of non-equal sets: A equals 1, 2, 3, 4. B equals 1, 2, 3. B does not have the same values in it that A does, so the sets are non-equal. 2 sets A and B are equivalent if they have the same number of elements. N of A has to equal N of B. Are the sets equivalent? The first set, 0, 1, 2, 3, 4, has 5 elements. The set 0, 1, 2, 3 has 4 elements. No, the sets are not equivalent. If we look at the next 2 sets, 1, 2, 3, 4 has 4 elements. 3, 4, 5, 6 has 4 elements. Yes, the sets are equivalent. They have the same number of elements. Equal sets are equivalent, but equivalent sets are not necessarily equal.